We're looking at another trig modelling question here, but on this one I do not have the values of A, B, C and D, but what I do have is some information. So you might want to pause the video and try and do some of these questions on your own or get a feel for it as it stands. So it takes 30 minutes for the Ferris wheel to complete a revolution. So that must mean that my period is 30 minutes. So my period is 30 minutes. One revolution, one full turn, 30 minutes. I could leap in fact I'm going to do that now. I'm going to work out my B value because my B value does the period. Now what I normally do for sine or cosine is my B value starts at, for a cosine or a sine curve is always 2 pi. I divide it by my B value and I get the period, which is 30. Therefore, if I do that rearrangement, B equals 2 pi divided by 30. So B will be pi divided by 15. So that's the first bit. So I've just already dealt with this. Now the radius of the Ferris wheel is 25. Okay. The highest point it reaches is 55. Passengers get on at the lowest point when h is 5 and the time is 0. So I'm going to just fill something in on my graph. Here is the lowest point and that's 0 and 5. The highest point is up here and that is something 55. I'm just going to complete something because I know one complete turn comes down to here and one complete turn is going to be 30 minutes and it should be back at the bottom of its cycle at 5. So I could start to fill this in as my one complete turn. Now, because I go from 55 to 5, that means that I've got 50, and that means that my amplitude or my A value is half of 50, which is 25. And look at that, that's also the radius of the Ferris wheel. I can also get my D because that's the principal axis. Halfway between 5 and 55, my principal axis will be 30 or y equals 30. So I've got everything now apart from the C value. So I've ticked that one, I've used all these. The only thing I haven't got is my C value. So to get my C value, let's look at the highest point here. Now obviously 0 to 30, the highest point here would have to be 15. So I've gone like this up to 15, and again hopefully your sine curve will be a bit smoother than the one that I've drawn, but it looks something like that. Now before I start moving anything around, I would have had my highest point at pi over 2 and 1. Now the 1 has been transformed to turn it into the 55 by using the A and the D. But the x number 15 has been transformed by using this b over pi over 15. Now inside the bracket, if I put b as pi over 15, that's fine, but it does the reverse to the actual number. So it takes 15 divided by pi, and I multiply that by my highest point, which was pi over 2. Now if I do that, I get 7.5. So what that's saying is I was at 7.5 here before I shifted it across. Now if I go that way, it's negative, and that means that I must have made the shift or the C value negative 7.5. So a phase shift to 7.5, but the C value in there is 7.5. And just to show you, if we look at this graph, I've done this one out on Desmos. Here's the green graph where I've done everything until I did the phase shift. So I knew the 25, I knew the 30, and I knew the period. Now I've just put that phase shift in there just to show you how it transforms across. So that is going to be a tricky question to do in an exam, but it is doable if you remember to reverse the operation of b.